Hey Omar, we're about done with breakout sessions. Hey everyone.
Hello.
Hi, how's it going?
Good. So what? Yeah, only origin and initial vectors is that's all you need to do here. Actually, we're gonna close down the breakout sessions. We're gonna do the rest of this problem together.
Okay.
Okay.
How do we
Okay.
leave?
Sounds good.
Do we
Oh,
just submit what we have right now?
Yep. Just submit what you've got.
Okay.
And we can just like scan it if we have it on paper.
Yep.
Okay.
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 how do we leave the breakout room?
I think it's a red button.
Oh, okay.
Oh, okay. Yes. No, not leave meeting or session. Where is it? Oh, top left corner says breakout sessions. Just click leave breakout session.
Oh, okay. Okay. And-
I'll automatically close in about a minute.
Oh, here it is. Leave breakout session. There it is.
Quick question. So when you mean submit assignment, I just took a picture of my notebook. Do we just submit it to the quiz thing right now? Or do you want the whole, like, after?
Nope, just submit whatever you've got right now.
Oh, okay.
Is a picture okay, or do we have to convert it into a PDF document?
Any image format is okay.
Okay, thank you.
Yep. All right. So that quiz is more to let me know how you're doing at the problem solving method that we started talking about last week. Let's break this down.
Oh wait, I haven't submitted mine yet, so is that a problem before you can, do I need to do that before you break this down?
No, that's fine.
Okay.
Okay. So I had drawn the picture. Your first task on this picture is to decide what your coordinates were going to be like. So you have to decide what's going to be the positive x direction, what's going to be the positive y direction. And I think it probably makes sense to say that to the right is the positive x direction and that up is the positive y direction with this problem. Also, I think it probably makes sense to say that the origin is where the ball was kicked from. So that's going to be our initial position there. With that decision out of the way, we need to write down in vector format all of the information that we've got. So our initial position is the origin. Our final position will be the bar of the uprights, so it'll be at coordinates 33. Our initial velocity, we know the speed but not direction of this thing. So if we draw a little triangle to help ourselves real quick. There's the initial velocity, and it's got an x part, and it's got a y part. We don't actually know what this angle is, but we can write it down as a function of the variable anyway. So we can write this down as 20 cosine theta. Cosine for the x direction because the x leg here is adjacent to this angle. And then 20 sine theta because the y leg is opposite of that angle. The only acceleration we're going to experience here is gravity. And like usual, I'm just going to round that to 10. Negative because gravity is going down, and we've said that up is the positive direction. And lastly, we don't know how long this trip is going to take. So there. What I've written in blue is what I was asking for from this quiz. Questions or comments on this bit in light blue?
I have a question.
Yep.
So our group got the first three, but then when we got to velocity original, we actually tried to figure out theta by using tan, going opposite over Jason and plugging in 3 over 30. And I don't know why my brain went there. I won't blame that on anyone else. But I ended up putting 20 sine, and then I tried to figure out one of the thetas, and I put 6.3.
Yeah, so you tried to make this triangle here,
Yes.
which is not quite the same.
Okay.
Right? So what you've got here is this is the angle that our final displacement vector would have. So you figured out the angle for S here. Which is, it's a useful thing to know, perhaps, but it's not the angle for V0. Does that make sense?
Yes, it does.
Okay.
Thank you.
The theta that I wrote down in blue here is just a generic, could be theta 1 or theta 2. Whatever the angle is, that'll be the expression for V naught. By the way, you'll hear me say V naught or V0 interchangeably. If with either of those, what I mean is V with a subscript of 0. Hey, don't apologize. This is our first quiz. We are all still learning how this goes. Don't even worry about it. All right. Let's go on to the physics of the situation. Is acceleration for gravity ever positive? That is an excellent question. And the answer is yes. It certainly could be positive if we said that down was the positive direction. What direction is the triangle supposed to be facing? Is that not at the kicker's foot? Oh, you mean the blue triangle I drew off to the left here? Yeah, I'm just bad at freehanding angles. So the S with an arrow, yeah, so the S, S sub 0 and S, those are both displacement vectors. All right, so we've got three possibilities for physics that could be used to explain this situation. So we've got our three kinematics equations. The values for acceleration, yeah, the negative 10 because the acceleration due to gravity is 9.8 meters per second squared, and I just rounded that to 10. It's important to know that G has a more precise value, but generally I'm not going to bother with using it because every moment that we spend whipping out a scientific calculator to get a precise number is a moment that we don't spend going over a tricky detail of a problem.
We do need to use the actual number in tests, though, right?
Nope. Make sure you use 9.81 in your lab because your lab instructor might care, but I don't care.
Okay.
All right, so we've got our three kinematic equations, and 80% of the time, it's going to be this one, right? We're going to care about distance, velocity, acceleration. 80% of the time, it'll be the first one. 15% of the time, it'll be the second one. 5% of the time, it'll be the last one. And here, we are definitely going to use the first one. Now, if we do a quick check of things that we don't know, in our vector breakdown here, we don't know theta and we don't know t. So that's two unknowns. To solve for two unknowns, we're going to have to write down two equations. Fortunately, we can apply our first kinematic equation here and break it down into the x direction and the y direction. That gives us two equations. So, in principle at least, we can solve this thing. So in the x direction, we can write down 30, that's our final position, equals our initial position in the x direction, which is 0, plus our initial velocity times time, so 20 cosine theta t, plus 1/2 at squared, but our acceleration in the x direction is 0. So we just have 30 equals 20 cosine theta t. In the y direction, our final position is 3. Sorry, position displacement. Our initial displacement is 0. Our initial velocity is 20 sine theta times time, and when we have 1/2 at squared, while our acceleration is minus 10, half that's minus 5, so minus 5t squared. Okay. Comments or questions?
Yes, please. So all we're doing here is just adding all the x values from the vectors that we broke down and the y values, right?
That's right. So we broke down all our vectors already, so it's really easy to just pick the x parts and make one equation out of them, and then pick the y parts, make one equation out of them.
So we're using the same exact equation, but we're using one for x and one for y.
Correct.
Right?
Yes.
Okay, perfect. Thank you.
And so that's two independent pieces of information we have about this this projectile.
Just one last one too. Why did we put -5 for the acceleration and not 10?
Oh, it's -10, but then times a half from our equation.
So we solved it already. Okay, thank you.
Okay, we're done with step 4. That's all the physics. Now we just have to do some math. So we have two equations and two unknowns. So in principle, we can take one equation, solve for a variable, plug that expression for that variable into our second equation, solve again, get a number. There are some things that complicates this in this case. So here we have one of our variables is encased inside a trig function. That makes it a little more complicated. And in the y direction, we have both a first and second power of one of our variables. So that makes it a little more complicated. So even though the x direction is not perfectly simple because it's got a trig function thrown in there, it's simpler than the y direction though. So start with the x direction, and we'll do the simplest solve that we can. So the simplest thing to do is solve for t. If we solve for theta, there'd be an arc cosine around everything, and then we would have to plug it in here, and we'd end up taking the sine of an arc cosine. And you know, you can do that, but I'd rather not. So instead, I'm going to say let's solve for t in this x direction. So t equals 3/2, where I reduced 30 over 20 to 3/2. Cosine theta. Now, okay, so we're done with the x direction. So let's take this this expression for t. Hold on, guys. I've made a terrible mistake.